Hi everybody, today I'm going to give you some notes on Module 2.7 and 2.8, so make sure you head your notes that way. Calculator, I hope you've got it ready, and some pencil and paper. We're going to talk about simplifying algebraic expressions. Oh good gracious, that just means stuff that has variables in it, all right? Dividing fractions, I think we might need a little review on that because that's always somewhat tricky for kids. So let's look at the first one, 4 divided by 2. Now most of you know that 4 divided into parts of 2, it would be 2, right? If you have 4 and it's asking you how many sets of 2, how many pairs of 2 are in 4, you say, well, there's a pair of 2, there's a pair of 2, so 4 divided into 2s, you got 2 groups. 4 divided by 1/2, I do still get people who tell me that's 2, but it's not. 4 divided by 1/2 means how many 1/2s are in 4. So I want to, this is a strange question, but the way it looks here is I've got 4 pizzas drawn. They're very plain pizzas. I've got 4 pizzas drawn, and I'm going to ask how many half pizzas are there. So we'll just draw them. How many half pizzas are there? How many halves are there in 4? And if we divide all these pizzas in half, you can see there's 1, 2, 3, 4, 5, 6, 7, 8 halves. And that is actually the correct answer for that. Try that in your calculator, 4 divided by 1/2 or 4 divided by 0.5, and you'll get 8. It's kind of interesting. So to divide fractions there, I'm going to give you some fancy words here. You've probably heard them before. But to divide fractions without having to draw them out like I did, you want to multiply. We always rather multiply. Multiplying fractions just straight across the top, straight across the bottom. It's easy. So we're going to change it to multiply, but we're going to multiply by the reciprocal. If you don't know what a reciprocal is, it means you just flip the fraction. Okay? That's what my students tell me. That's the word you guys usually use. So I'm going to do the same example we just did, that we know the answer, that there are 8 halves in 4 pizzas, right? 4 divided by 1/2 is 8. But I'm going to show it to you without drawing. We'll just take 4, and instead of division, we're going to multiply by the reciprocal. If you flip 1 over 2, you get 2 over 1, right? And now we're going to multiply straight across the top, straight across the bottom. Now 4 doesn't have a bottom, so remember, 4 is the same as 4 divided by 1. Fraction bar just means division. And now it's very easy to multiply straight across the top and straight across the bottom, and we can simplify that. 8 divided by 1 is just 8. Let's try a couple more. I want to make sure that you got this. I have 3 more examples here, and then we'll move on. 5 divided by x over 2. We do not like to divide fractions, so we're going to change it to multiply by the reciprocal. I put an x in there, so now it's an algebraic expression, right? We would like to multiply fractions. We'd like them both to be fractions. So I'm going to make the 5 a fraction. And then I'm going to multiply straight across the top. 5 times 2 is 10. Straight across the bottom, 1 times x is x. And since I don't know x, I can't do a darn thing. I'm going to circle that answer, and I'm going to be done with it. If you'd like to pause me and try the next one, feel free. All right, so I'm going to take 16, and I'm going to multiply by the reciprocal. 2 over negative y is fine. I'm going to make the 16 a fraction. And when I multiply 16 times 2, you may use a calculator. And in the bottom, 1 times a negative y. Well, a positive times a negative is negative. 1 times y is y. I don't know what y is, so I can't do anything else with that. And the very last one I'm going to have you look at is this one. So like I said, feel free to pause me and try it on your own. That's absolutely fine. I'm going to take 32, multiply by the reciprocal, 4 over negative x. I would like 32 to be a fraction. And I'm going to multiply 4 times 32, which is 128. And 1 times negative x, positive times a negative is negative. 1 times x is x. I can't simplify that at all. I'm done. Okay, The last part of this, simplifying algebraic fractions, you'll have several questions like that on your CK12. I'd love for you to have your notes out when you do that CK12 assignment, and a calculator, of course. Okay, let's talk a little more about simplifying. Simplifying, really, in algebra, you do two things. You distribute, and I'm going to show you what that is. If you've forgotten, it's okay. You distribute, that's the same as multiplying, and then you combine like terms. That's pretty much like adding and subtracting. So just like order of operations, we're going to multiply before we add and subtract. Okay, like terms. Oh, what are those? Like terms means that they have the same variable and it's raised to the same power or the same exponent. You'll see power, exponent. You'll even see some people refer to it as what degree is that. You know, if it's a second degree, it means it's squared. A third degree is to the third power. So you may even see that. I'll usually use the word power or exponent. And terms, if you're not sure, it's just anything that's added or subtracted. So let's look at an example. 2x plus 7 plus 3x plus 1. That's 4 terms. That's being added to that. So one term separated by a plus or minus. That's another term. Plus or minus. That's another term. Plus or minus. And there's our fourth term. 4 terms. And now we'll look for like terms. So same variable, same exponent. I've got a 2x. That's a positive 2x. And a 3x. That's a positive 3x. So I would have 5 x's altogether. Just like having 2 apples plus 3 more apples, you got 5 apples. And these constants are like terms also. They have no variable. 7 plus 1, positive 7, positive 1, that would be plus 8. And there's absolutely nothing else I can do with that. Simplifying is kind of blah, right? Once you have no more like terms, then you're done. And that's sometimes the hardest part of algebra, is knowing when you're done. You got no more like terms, you got to be done. Okay, so let's take a quick look. And you can pause me and go ahead and see if you can figure out how many terms this has. And then combine the like terms. Okay, 1, 2, 3, 4, 5 terms. And the like terms are all the ones with x's. So I have a negative 3x and a positive 5x. So negative 3 plus 5, that's 2. And then I'm going to minus another x. This is just a 1x. So this makes 2x minus 1x. Just give me 1x. There you go. And then I'll combine the constants. A negative 10 and a positive 1 is a minus 9. And since those aren't like terms, we're done. Okay, if you want to pause me and try the next one, please do. 1, 2, 3, 4, 5, 6. This has 6 terms. And now we've got x squared, so positive 6x squared and a negative 2x squared. So I have 6x squareds, and I'm taking away 2x squareds. That's going to leave me with 4x squareds. I have a positive 4x, which is like a 7x, because they both have an x to the first power. 4 minus 3 minus 7 would be negative 3 x's. And then I have a negative 7 and a positive 8. So on the number line, if we're at negative 7 and we move 8 to the right, because positives are right, I will get a 1. There are no more like terms in here, so you're done. The last thing I'm going to do is give you a few problems with distribution, see if I can help you out with any of that. Make sure we understand that you distribute when a number or a variable is multiplied by a quantity. A quantity is just stuff added in parentheses, okay? So because we're taking 2 times this whole quantity, I have to take 2 times the x, times by every term, and 2 times the 4. If I had a whole bunch of other terms added and subtracted, I'd have to take 2 times all of those, but I just stuck with 2. These aren't like terms, so we're done. Then over here, if you want to pause me and give this one a try, please do, and then come back and check your answer. This is 3 times a quantity. There's 2 terms in here. Terms are separated by a plus or minus sign. So I'm going to take 3 times x. 3 times x, it was written 3x. And I can actually do 3 times negative 2. Positive times a negative is negative. 3 times 2 is 6. Okay, the next one's a little bit different. I'm going to adjust this so we can see it. We're almost done here. And let's go with distributing first. There is an order to doing things. We should distribute and then combine like terms. So we're going to take care of multiplication first. The 3 is being multiplied only times the quantity. So 3 times x is 3x. And 3 times negative 2 is negative 6. The 3 is not being times by the 5x. The 5x is not in the quantity, so we haven't done anything to that. Now that we've multiplied, we've distributed, now we can combine the like terms. 3x positive, 5x is positive, that gives us 8x's. And then this negative 6 doesn't have anything like it. And when you have no more like terms, you're done. Okay, I'm going to look at the next one over here. This time we have a variable out front. It's x times x, which is x squared. X times 3 is 3x, and it would be positive. These are not like terms, so I'm done. That easy. Okay, the very last one that I want to look at with you is this one. And that's the x is being times only by the quantity. So x times 4 is 4x. Now I have an x times 2 more copies of x. That gives me 3 x's multiplied together. That's written as x to the third. The 5x is not in the quantity, so it doesn't get multiplied. And then I'm going to combine like terms. We've got a 4x and a 5x. That's a 9x. And a positive x cubed. It's a positive 9x. And a positive x cubed. I like to put the highest power thing out front. That's called a standard form. It's the way most of your answers will be written. All right, folks. Thank you.